Hello friends, in the last lecture we have discussed P.M.F of Binomial Distribution. Today we will see some more examples of binomial distribution. As we have discussed, P.M.F of binomial distribution is NCX p raised to x q raised to n minus x if x is 0 on top to n and otherwise 0. Then properties, mean of binomial distribution is NP, variance is NPQ, mean is always greater than variance, P plus Q is equal to 1. These are some properties of binomial distribution. Then we will see some examples. An unbiased coin is tossed 4 times. What is probability of getting 3 heads? Second, at least 1 head. Solution. Here x is number of heads. For tossing a coin, value of P means probability of head occur on uppermost face is 0.5 and Q is 1 minus P means 1 minus 0.5 which is again 0.5. Then first case, probability of 3 heads. This is equal to probability of x is equal to 3. Here value of n is 4. P of x equal to 3 is NCX P raised to x q raised to n minus x. Here n is 4. 4c x is 3. P 0.5 raised to x is 3. Q 0.5 raised to n minus x, n is 4. 4 minus 3. This is equal to 4 factorial upon n. 4c3 is 4 factorial upon 4 minus 3 factorial into 3 factorial into 0.5 raised to 3 into 0.5 raised to 4 minus 3. 4 minus 3 is 1. This is equal to 4 factorial upon 4 minus 3 factorial means 1 factorial into 3 factorial into 0.5 raised to 3 into 0.5 raised to 1. This is equal to 4 factorial. We can write 4 into 3 factorial upon 3 factorial into 0.5 raised to 4. This 3 factorial is cancelled with this 3 factorial and finally we get 4 into 0.5 raised to 4. If we calculate this, we get final answer 0.25. Probability of at least one head is equal to probability of x greater than equal to 1. Its complement is 1 minus probability of x less than 1. Probability of x less than 1 means probability of x equal to 0. This is equal to NC0 p raised to 0 q raised to n minus 0. This is equal to 1 minus NC0. Here n is 4. 4C0 p means 0.5 raised to 0. 0.5 raised to 0. This is equal to 1 minus 4C0 into 0.5 raised to 4. 0.5 raised to 4. If we calculate, we get 0.0625 and 1 minus 0.0625 is 0.9375. Final answer is 0.9375. The probability of at least one head is 0.9375. Then we take one more example. If mean of binomial distribution with 6 trial is 2, find the probability of at least 5 successes. Here mean of binomial distribution is 2 and 6 trials are given, so n is 6. 6p is 2, therefore p is 2.6 means 1 upon 3. Then p plus q is 1 and p is 1 upon 3. Therefore, value of q is 1 minus 1 upon 3 and 1 minus 1 upon 3 is 2 upon 3. Hence, P is 1 upon 3, Q is 2 upon 3, and N is 6. Then here we have to find probability of at least 5 successes. Probability of at least 5 successes is equal to probability of x greater than or equal to 5. This is equal to probability of x equal to 5 plus probability of x equal to 6. Here value of n is 6, so we go up to 6. For probability of x equal to 5, its formula is 6c5. P means 1 upon 3 raised to 5 into Q means 2 upon 3 raised to 6 minus 5 means 1 plus 6c6. P means 1 upon 3 raised to 6. Q means 2 upon 3 raised to 6 minus 6, which is 0. Therefore, this is equal to 6 factorial. NC 6 factorial upon 6 minus 5 means 1 factorial into 5 factorial into 1 upon 3 raised to 5 into 2 upon 3 raised to 1 plus 6 means 6 factorial upon 6 minus 6 factorial into 6 factorial. This is equal to 1 into 1 upon 3 raised to 6. 2 upon 3 raised to 0 is 1. 6 into 5 factorial upon 5 factorial into 1 upon 3 raised to, this is 1 upon 3 raised to 5, and here 1 upon 3. We can write this as 1 upon 3 raised to 6 into 2 plus 1 upon 3 raised to 6. Then here 1 upon 3 raised to 6, here also 1 upon 3 raised to 6. We can take this outside this bracket. We get this 5 factorial is cancelled with this 5 factorial, so 6 into 2 plus 1, this is equal to 1 upon 3 raised to 6 into 6 into 2 is 12. 12 plus 1 is 13, and final answer 13 upon 729 is equal to 0.0178. Probability of at least 5 successes is 0.0178. A helpline claims that 90% of their customers are given help if 10 customers are selected at random. Find probability that out of them the number of customers helped is exactly 6 and second more than 8. Solution: here a helpline claims that 90% of their customers are given help, therefore P means probability of success. This is 90 upon 100. 90 upon 100 means 0.9. Therefore, as P plus Q is equal to 1, 0.9 plus Q is 1, hence Q is 0.1. So P is 0.9 and Q is 0.1. Then if 10 customers are selected at random means value of N is 10. Find probability that out of them the number of customers helped is exactly 6. So we have to find value of probability of x equal to 6. Its formula is 10c6. P means 0.9 raised to 6 into Q means 0.1 raised to n minus x. N is 10, x is 6. 10 minus 6 is 4. This is equal to 10c6. We can write this as 10 factorial upon 10 minus 6 factorial into 6 factorial into 0.9 raised to 6 into 0.1 raised to 4. This is equal to 10 into 9 into 8 into 7 into 6 factorial upon 10 minus 6 factorial is 4 factorial into 6 factorial into 0.9 raised to 6 into 0.1 raised to 4. We cancel this 6 factorial with this 6 factorial. 10 into 9 into 8 into 7 upon 4 into 3 into 2 into 1 into 0.9 raised to 6 into 0.1 raised to 4. 4 2s are 8, 8 is cancelled with this 8. 3 3s are 9, so 10 into 3 into 7 into 0.9 raised to 6 into 0.1 raised to 4. This is equal to 0.0112. If we calculate this, we get final answer 0.0112. Then second, probability of x greater than 8, more than 8 means probability of x greater than 8. This is equal to probability of x equal to 9 plus probability of x equal to 10. This is equal to 10. C value of n is 10. 10cx p means 0.9 raised to x into q 0.1 raised to n minus x. 10 minus 9 is 1 plus, for this 10c10 into p 0.9 raised to 10, then q is 0.1 raised to n minus x. N is 10, x is 10, so 10 minus 10 is 0. This is equal to 10 this 10c9 is 10 factorial upon 10 minus 9. 10 minus 9 is 1 factorial into 9 factorial into 0.9 raised to 9 into 0.1 raised to 1. 10c10 factorial means 10 factorial upon 10 minus 10 factorial into 10 factorial. This is equal to 1 into 0.9 raised to 10 into 0.1 raised to 0. This is equal to 10 factorial upon 9 factorial. It's 10 into 9 factorial upon 9 factorial. This is equal to 10 into 9 factorial. 9 factorial will get cancelled into 0.9 raised to 9 into 0.1 plus here 0.9 raised to 10 into 1. If we calculate this, we get 0.3875 into this 10 into 1, 10 into 0.1 is 1 plus 0.3488, and this is equal to 0.7363. So final answer probability of x greater than 8 is equal to 0.7363. Then take one more example. For a binomial where x is with usual notation p is equal to q, probability of x equal to 2 is equal to probability of x equal to 3 is given. Find probability of x equal to 1. Solution: given p is equal to q and we know that p plus q is 1. Here p is equal to p, replace q by p, then we get p plus p is 1, means 2p is 1, means p is half, and p is equal to q, therefore p is half and q is again half, therefore p is equal to q is equal to half. Also given probability of x equal to 2 is equal to probability of x equal to 3. For probability of x equal to 2, our formula is NC x is 2, p raised to x, q raised to n minus x. For probability of x equal to 3, our formula is NC x is 3, p raised to x, q raised to n minus x. Here p is half, q is half, x is 2, therefore NC2. P means half raised to 2, Q is again half raised to n minus 2. This is equal to NC3. P is half raised to 3, Q is again half raised to n minus 3. This is equal to NC2 n factorial upon n minus 2 factorial into 2 factorial. Half raised to 2 into half raised to n minus 2. We can write it as half raised to 2 plus n minus 2. This is equal to n factorial. NC3 is n factorial upon n minus 3 factorial into 3 factorial into half raised to 3 plus n minus 3. Therefore, here this n factorial is cancelled with this n factorial. 1 upon n minus 2 factorial into 2 factorial into half raised to 2 plus n minus 2 is n. This is equal to 1 upon n minus 3 factorial into 3 factorial into half raised to 3 plus n minus 3 is n. This half raised to n is cancelled with this half raised to n. Therefore, here this 3 factorial upon 2 factorial by cross multiplication is equal to n minus 2 factorial upon n minus 3 factorial. And we know that formula n factorial we can write it as n into n minus 1 factorial. So here we use this formula for n minus 2. We can write 3 factorial as 3 into 2 factorial upon this 2 factorial is equal to n minus 2 factorial. We can write it as n minus 2 into n minus 3 factorial upon n minus 3 factorial. This n minus 3 factorial is cancelled with this n minus 3 factorial. This 2 factorial is cancelled with this 2 factorial. Therefore, 3 is equal to n minus 2, or we can write this as n is 3 plus 2, means value of n is 5. Value of n is 5. Here P is, therefore here P is equal to Q is equal to half, and as we have calculated n is 5 and n is equal to 5, value of P of x equal to 1. For P of x equal to 1, our formula is NCx P raised to x Q raised to n minus x. This is equal to value of n is 5, C, x is 1, P is half raised to x into half raised to n minus x, n is 5, x is 1, 5 factorial upon 5 minus 1 factorial into 1 factorial into half raised to 1 into half raised to 5 minus 1 is 4. 5 factorial we can write it as 5 into 4 factorial upon 5 minus 1 factorial means 4 factorial. 1 factorial is 1 into half raised to this 1 plus this 4 is equal to, we cancel this 4 factorial with this 4 factorial, is equal to 5 into half raised to 5. 5 into half raised to 5, and final answer is 0.1562. Therefore, probability of x equal to 1, 0.1562.